Hey everybody, Jay here from the MARZ Project. I can't listen to myself while I'm doing this. It throws me off so much. Yeah, so today Corey's going to take over and do another demonstration on how to, record and then actually the post-production of taking those recordings and putting them into post-production. So he's going to give us a little overview about that, and I'm going to hang out back here, run the stream, and ask questions. And please feel free to comment and ask us questions. And I guess I'll hand it over to Corey, and we'll get started.
Hello. So, here we are, back again. Audio stuff. So, last week at our Access class, we were talking about just kind of like pre-production stuff for audio recording, going over things like microphone choice and that sort of stuff, how to pick a microphone for your application, blah blah blah. We're talking about like signal flow and all that kind of stuff. If you want to remember what we talked about, It's still archived on the YouTubes.
Go watch it.
Go watch it. It's a little long, so apologies. It takes a while to get to the good stuff. We were having a lot of fun. So today I mostly want to I want to kind of pick up where that left off and just kind of like talk about like if we're in a situation where we know what we're going to record and we've like chosen what gear we're going to use to do it with. What does the actual recording look like, and what do you need to keep in mind as a recording engineer if you're recording something? What do you need to know if you're a talent on the other side of the microphone? So we're going to try and cover all that right now. So we talked a lot about like I'm kicking my chair down here. I should really sub this out for the non. Chair. Oh, well, next time.
That one's just more comfortable.
It sure is. So yeah, we talked a bunch last time about like different microphones for different applications, whether you're indoors or outdoors, recording instruments or voices, what instrument you're recording, whether it needs to be on or off camera or hidden behind someone's clothes. There's a bunch of different mics you can choose. But we're going to like assume that you've chosen the right mic for your application at this point. And so now it's like recording day, right? So you've got all your gear together, you're going to the location, whether it's a studio or like out somewhere on set, or just out in the world, and you're going to start capturing sound. So what do you need to like think about? So like the gear you're going to have with you is you're going to have a microphone, some way to catch the sound. You're going to have some sort of recorder, usually with like built-in preamps, to amplify the volume of the microphone and then capture the sound. And then you'll probably need some headphones to hear what you're doing. And so you've got all that stuff, you're ready to record. So like what that looks like obviously differs greatly depending on where you are and what you are recording. Today we're going to use my voice as an example. I have this microphone set up. This is the what is this thing called? The Rode M3. It is a medium diaphragm condenser microphone. Kind of based on if anyone's seen the old C1000, that classic AKG mic that everyone loves to hate. This is like a slightly nicer version of that. It's got a switch here for a low cut, and that's the only control on it. I'll probably engage that because I'm not a bass singer and don't plan on singing any bass lines today, so we'll keep it just like that. So remember we talked about like controlling sound in your space with the use of like pop filters and dead cats and stuff like that last time. So I'm gonna chuck this filter on this, even though I probably don't need it, just in case I blow on it or something like that. It'll help catch a little bit of that wind noise. Like I said last time, these guys aren't the best for actually blocking wind. It's more for plosives from your breath, and that there's a different tool for that. The dead cat that Jay's got over on his mic that you can't see because it's on top of his camera.
It is.
But yeah, so we've got a microphone set up, got my voice. So something to keep in mind, like if you're inside and recording, so that like as a music guy, like we tend to record in controlled spaces more often, where the extraneous noise becomes a factor. I don't know if y'all could hear that big truck just driving by outside, but there's extraneous noise is a factor in this building. So like for certain kinds of recordings, we can't do them here because it's not sound isolated enough. From noise from the outside. But assuming you have like a reasonably sound isolated environment, there's things you can do to make it sound better within that environment before you even turn anything on. And so, can you grab me that blanket?
Oh yeah.
Give me a blankie, please. So I want to talk about like a few different things you can do to just like make things sound better in the space. One thing is position your microphone correctly. So like, this is an end address microphone. If I have it pointed like this and try and talk into it, it's not going to work very well. It's going to hear mostly from up there. It'll still pick me up just fine, but it's going to be a lower quality sound. It'll be quieter and like weirder sounding than if I was directly on axis. You get a much fuller, richer sound. And also the distance from your source matters. Getting too close can be kind of negative, but getting far away becomes roomy. So right, remember the mic isn't selective; it just hears whatever it hears. So the further away I am from the mic, the more the sound of the room comes in. I don't know if you can tell I'm talking into this boom mic over here, but if I get a little closer, I should feel a lot more present. And then as I drift off, you should hear a little more room tone. And if I get off axis from this mic, it should get even a little stranger sounding.
Especially if I talk over here with my mic muted.
Oh yeah.
I sound like really far, and I'm right at an angle from.
Yeah, Jay's super off axis. Jay's about as close to the rejection point of that mic as he could get in that position. So, like, you can use this to your advantage. Like, remember we talked about Mike's polar patterns? Go watch the last video if you need to review that. If you know where the null points of your mic's polar pattern are, you can aim that at a noisy source. So, like, if I was recording this in here and Jay was going to talk and I wanted a nice clean signal, I'd try my best to point the back of this mic towards him. You know, like compromising for, like, obviously the most important thing is that it's pointed at my mouth. But like, if I can aim it like this, that's going to pick up more of Jay than if I aim it like this, where the back is pointing directly at him.
Is there a way we can demo that?
I don't know, like, how audible it will be over the, like, with the compression of the stream.
Oh, okay.
You know, well, so
if you're monitoring it on your computer.
Oh, right, yeah.
Then we should be able to hear it.
So the other thing about it is, like, because we're in a relatively small room, the reflections in the room are going to bounce into those nulls, or bounce away from those nulls and come back into the mic in some way. But we can see if we can see what we can see. So I'll turn this mic on. I've got my headphones on so I can hear what it's up to.
I'll turn this one all the way down.
Give me just 1 second. Boom. So, this sounds pretty crazy to me. I'm getting some phasiness for some reason. Why is that phasey sounding? Oh. Because I was direct monitoring and indirect monitoring. Hey, this is touching on something that I want to talk about. Monitoring. Let's see. That is... How's that? Great. Cool. So, I'm not sure if y'all can hear Jay right now. I'm just going to point the mic at him. Say something, Jay.
Hello? Can you hear me?
I can hear you now, actually.
Yeah.
And I feel like I'm probably kind of quiet.
Yeah, definitely.
In my headphones, we sound almost the same volume, actually.
That's crazy.
Like, that's pretty bizarre. So that's a pretty great illustration of the rejection point. So as I drift off axis of this mic, I start being more and more rejected, right? Like, so here I am, like, I'm still really close to the capsule, but I'm not nearly as loud as I was when I was head on. This is the cardioid pickup pattern. And so as I get further and further off axis, it stops making much sound at all.
That's pretty impressive for that mic.
Yeah, I think it might be a super cardioid kind of pattern actually on this thing. I forget. Let's look up the specs real quick. Rode M3. I like Rode's website because they're very clear about their specs. They're usually really easy to find. Let's see.
Definitely have to be right up on it though.
Yeah, where does it say? Oh, it's interesting. So it must just be cardioid because it doesn't say anywhere. Here's specs. Weird. A capsule. Just 0.5. Oh, that's so funny. Usually they're really explicit about their polar patterns on here.
Yeah.
But I don't see a but on this thing either. I'm so curious though. What is it? Why don't I know that? Aha. Cardioid.
Yeah.
Surprise, surprise. Like they all are.
Seems like pretty solid.
Yeah, so that's like so cardioid is the standard rejection pattern. So like
right.
Just to be clear again, like this chart here is a map of like how loud a given frequency is when it is like off of axis of the mic. So again, like this is up at the top, 0 degrees, completely on axis. This is at the bottom, 180 degrees, completely off axis. This is 270 degrees. So you can see that like it's really dramatic actually. So you can use this to your advantage. So like if you're the only person in the room, you might think about like pointing the back of your mic towards any like a window where noise might come from. Or like if you have like, I don't know, like if you're recording in the room with a PC tower that has some loud fans, point the back of this thing towards your PC. You'll be glad you did. The other thing to think about though is that like the mic's sensitive from this end. And so if I'm pointing this at a noisy source, it's picking up all the stuff behind me too. And so my voice bounces off that wall and off of this wall. So if you're recording inside a space, it can be really helpful to like control the sound in that space somehow. So there's a few different ways you can do that. If you're feeling really fancy, you can like put up like proper like acoustic treatment on your walls, like we have in the main MARZ studio. I meant to drag one of those panels out here one time. I never did. But we built these cool rock wool acoustic panels in there that sound amazing and just really effective at blocking sound. But like if you don't have if you're not ready to put holes in your wall, or like don't have the money to build, or the woodworking tools to build a bunch of frames for your panels or whatever, like you probably have some blankets around the house. So like I got this like moving blanket thing. We have a couple of these actually, and these make great like temporary sort of sound baffles. Now this is something that like I don't know that I'm being loud enough in this room that you're gonna like tell that this is happening, but like, you know, like you might like hang this up like behind you. And so like you have to find some way to support this, of course. But then like that's gonna keep like any like sound that reflects back is not gonna make it into the mic, like from behind me. So you hear people talk about making like a blanket fort when they record. This is like a pretty normal strategy to like get really clean sound without a room tone. So like for anyone who's like recording a podcast, you might consider doing this. It looks absurd, but no one's gonna see you on your podcast. So you know, like I wouldn't literally put it on top of my head for a variety of reasons. One of which is you're gonna knock things over. But I often like I'll use some like mic stands, or like if you have like lighting stands, or just like a chair, hang them from a door, like tack them to your wall. Anything you can do to reduce the number of hard reflective surfaces in the room will make a better sound, and you'll be glad you did. Jay's in the middle of editing some interviews we shot a couple weeks ago. I think I mentioned this in the last stream, but we recorded them in a big gallery room down the hall here, and that room has absolutely nothing in it. Like this room's got a couch and a bunch of equipment, and like it sounded pretty good in a lot of ways, but like that room was completely empty, and it just like
terrible acoustics.
Oh man, yeah. Well, I mean, the interviews turned out good. Like,
yeah,
and you did a great job of tweaking the audio to where like it works. But like, the room tone was a thing, and that was like a big struggle. Like if we were gonna do a bunch more interviews in there, I'd definitely be like putting up some sort of like acoustic treatment. That's the word. That if you're curious more about this subject, you can just do some searching for acoustic treatment, and this is what we're talking about. It's not soundproofing. Don't look up soundproofing. Different topic. It's a super huge common source of confusion. Soundproofing is preventing sound from entering or leaving a space. Sound treatment is just making a space sound nice. Right. Sound treatment is pretty simple and practical. You just reduce the number of hard reflective surfaces. That's like an extremely reductionist way to put it, but that's like
windows reflect. Are they like reflective for sound?
Yeah, absolutely.
Even though they're
visually transparent.
Right.
Yeah, totally. Yeah. No, like it's
glass reflects probably pretty well.
It's rock, it's just like glass is just like liquid rock that's slowly melting.
So if you had big windows, even just like hanging curtains over those windows would be really effective.
Yeah, totally. Yeah. It's that's like a huge problem in studios is windows.
Yeah.
Partially because they're more acoustically transparent in that they let sound in, and they will let some sound out, but they're also reflective in that they're a hard surface that sound will bounce off of. It's kind of like the worst of all worlds. If you go to like pro studios, like if they have windows, a lot of times they're like air gapped.
Oh, interesting.
So so now we're getting on to soundproofing. So sound treatment, you make the room sound nice, but if you want to keep sound from entering or leaving the room, then you get into soundproofing, which is like you're talking construction.
Right.
The only way to soundproof a space is to decouple the walls from the interior walls from the exterior walls, and that includes the floor.
I'm sure they do that in like apartment buildings a lot, like nicer apartment buildings.
Like
it's like an air gap between.
I would hope so.
Yeah, you if you're gonna pay, for a nice apartment.
Totally.
It's like, are these walls air gapped?
Yeah, I would certainly hope so. Yeah, so like this is why like recording studios exist, because like it's just not practical to build a floating room within a room of your rental. Right. Your landlord will hate you, and you'll have to take it apart when you leave, and you'll just be a miserable time. So unless you own where you live and can like convert it into a soundproof space, that's why people have recording studios.
What about like basements? Are those make pretty good like room proof? Like, so if you have like solid like ground, like dirt.
Yeah, totally. So there'll be like less transmission out for sure. It's largely about like it's either about air gap or mass. So like if you had like a house with like walls built out of like 3 feet of solid lead, like you probably wouldn't need an air gap. Right. But nobody wants to live in that house.
Those are probably still, even if it's, even if it's like noise or like, it's probably still not very absorbent. So
it's not at all.
Like concrete walls or like cinder block walls still.
Yeah, but like the absorption. Pretty much like when sound's leaking out of space like that, it's mostly it's like loud low frequencies. Right. I think we talked a little bit about the Fletcher Munson curve in here, which is like our ears have like like a little curve on them. Here, let me pull it up real quick.
All right.
Fletcher Munson curve. This is a nerdy thing. This is a diagram of how your ears hear. I'm pretty dang sure I've pulled this up in here before.
Yeah, I think maybe we talked about it a little bit last time.
Yeah. So basically, like the idea of this graph is that like. Basically, the lower the frequency, the more energy it takes, or the louder it needs to be for us to hear it at the same volume. So, like a 20 hertz tone at 70 dB SPL is equivalent to a 1000 hertz tone at about 1 dB.
So it's interesting because when I was editing these interviews we were talking about, I had the lady that we were interviewing. She had a very soft voice, and like it seemed like it was much quieter than I don't know. It's kind of weird. I guess it depends on the person and their voice, but like the guys would talk and it would be like seem like much louder, even though it probably was a lower frequency. On like as far as their speaking voice is probably a much lower frequency, but it seemed louder. Was that just like perceived volume, like loudness of just how we talked?
You're talking about in those interviews, like
right?
In
the interviews.
Yeah. I mean, it might just be as simple as like she was speaking a little quieter,
right?
But I wouldn't think that this would be coming into play in that scenario. Like what this is really about is about how it changes as things get louder. So why there's multiple lines here is that these are at different like volumes basically.
Right.
So like
it's very interesting. It'd be really cool to have like someone who's worked in like the film industry in that sort of sound area of like how they master for
cinema
soundstage.
Yeah,
it would be interesting because I know it's quite a bit different than like if you're mastering for music per se, or like a track that's going to go on Spotify or something.
Sure. Yeah. With like the goals are different, right? Like
right.
And like mastering music's largely about making things translate to a wide variety of playback systems.
Right.
Whereas I would think that mixing a movie is about making it sound awesome in a theater, specifically, right? Perhaps often to the detriment of the home release.
Right.
We've all watched like, I don't know. I've recently been re-binging some old movies and like noticing that like how quiet or like there's been a shift where like I think that maybe like when they're releasing things for home they're actually mixing them differently.
They could be, yeah.
Or at least like that they're getting like or they're just delivering the streaming mix which is louder. Because you like I was watching like old Star Wars movies and they're just mixed super quiet. And the new ones are mixed louder.
Yeah.
I don't know.
Interesting. Yeah. And I mean, it's just like I hate that in movies where you're like
turning it down, turning it up.
Yeah, where you like the dialogue's so quiet and
the
music is so loud.
So we'd say that it is like a little more dynamic than you'd prefer, right? Like there's like the quiet's a little too quiet compared to the louds, So like you might want like You know, you might like in music we worry a lot about the dynamic range of the whole thing. You know, like we want it to be nice and dynamic, but you also don't want it to be where someone's like turning it up, turning it down. It's uncomfortable viewing or listening experience. You know.
I think that's why it's great to like if you're doing this sort of stuff, if any kind of like small film project, if you're making it for college class or something, or to take it and like after you render it, take it and put it on your TV at home. Or play it on your speakers, or play it on different pairs of headphones. Listen to it on a whole range of different things, because like how you're mixing it, like you could have your volume up really loud, and not realize that you're mixing it at such a high volume, and then go and render it, and then you find out, hey, it was actually like I have to turn my TV up to like level 50, or whatever that whatever a TV means, but like. To actually hear anything, so it's like so weird. You definitely want to play it on something else, because then like I've seen that with other like with my peers when I was in going to CR. It was like somebody would edit their film and we would play it on the projector and it would be ridiculously loud, and then the next person's would be super super quiet. Mm-hmm. So like constantly having to ride the volume on the computer on the projector to like get it to where we could hear it, or that it's not like blowing out the speakers. Totally. So you're skipping ahead a little bit with this, but like this is why loudness standards exist, right?
We were talking about talking about the European broadcast standard -23, right? And so like if you adhere to that, like it's going to like be the same relative loudness as everything else.
Exactly.
And so like this is why we use reference tracks when mixing audio.
It's so important, and I feel like it's skipped over so much in like
that particular thing
classes.
I mean, like, I don't know, I can't remember how many years I spent working on music before someone was like, hey, you should probably use a reference track. I'm like, oh yeah. Like, like listen to someone else's track. How loud is their track? Make it that loud. If if it's good, like, if you're making rap music, put on some rap tracks. Like, how loud are they? If you're mixing like a little like documentary film, like check out a documentary film, or check out the loudness standards to which you were planning to distribute it. That's maybe even a better way to do it.
That's something we could do in a future thing.
Oh yeah.
I don't know about like the copyrights of using films, but maybe we could find something and take it apart and like look at the.
Oh yeah, chuck it in some meters.
Yeah.
I'm used to yeah.
That'd be kind of cool.
I don't know whether my meters would be that interesting for film audio, but I have nice metering tools over here. Yeah. Mostly audio's audio, right?
Be something for a future,
Yeah.
Maybe like when we do our, we thought about doing like a little mini production as we're going through, like doing a little film project. Maybe while we're doing the mastering for, our little film project, we can look at other films and see what they look like, as far as like the actual waveform breakdown.
I think I'd be happy to demonstrate maybe a mastering audio stream where we just talk about like what the job of like mastering is.
It's such a huge part.
Yeah, this is so last week was what like pre-production. This is like production and post-production. And so like mastering is like really it's a post-production. It's almost like a post-production thing. It's like you do the post-production and then someone else does more post-production too.
Yeah,
that's mastering.
Lots of layers.
Yeah, totally.
Yeah.
Yeah. Oh, there was something. Yeah, okay. Reference tracks. So that's super important. You were mentioning something about like you don't know whether or not you're listening to it loud or quiet. Like keeping in mind. So reference tracks help you catch that, right?
Right.
But also like people who are really serious about mixing stuff to standards. Like with music, like we're more concerned about just making it sound good. It's like like Spotify normalizes stuff and like whatever. Right. So it's like it's like if you listen to a record, as long as that record sounds good with itself, it doesn't really matter. And then if you're playing it like in a playlist, you're probably listening to it somewhere where it's like volume normalized or DJ's controlling it or whatever,
Yeah.
Blah blah.
What would you like lock your volume in place? Like not.
So like depending on what your volume control is like, like on the Focusrite right here, our volume controls are analog knobs.
Yeah.
So some people like mark a little point.
Okay. That makes sense.
There's even like recommended listening levels. I couldn't quote you the numbers, but like, so like if you were really caring about this a lot, you would like play a reference file through your speakers, measure the decibels, find the correct listening level, like the level at which you want it set, so that when a song is mastered to such and such loudness standards, it is this loud, Yeah. So that your monitoring is always consistent too.
Yeah.
That's a step that I have yet to take. But now I have this interface that has digital control over everything, so it's really easy. Like I can set the precise levels of everything every time. I call them as preset. This is an advantage to a slightly fancier audio interface with digital control. I kind of like didn't like it at first, the idea of the digital control. I was like, I like knobs for stuff, but like actually like this one has just like one knob, and then you like switch, you pick the channel you want to, but it's digitally controlled, so I can just set it and forget it. It's great.
Yeah, it's definitely like something that I've as you know, mainly you know, as a filmmaker, that whole sound thing, and I see even like professional like I mean, I guess like not necessarily professionals, but you know, the people that you call like independent filmmakers, you know, that are more like getting into, you know, kind of at that pseudo professional level, that still struggle with sound stuff, because it is like, it's so complicated in of itself that like it takes a lot to get it just right. And I mean, you can like, just like we were talking about, like watching we probably all watched a movie where we're being like, why is it so quiet? Why is the dialogue so quiet? And then the music's so loud. Like that's still someone whose job, like professionally, is to mix audio, and it still doesn't seem like.
Well, standards have changed too. So to the credit of those older like movies,
older
you
stuff.
know,
I mean,
like,
you still watch new movies where it's like you can't hear the people talking over the you know, over the dialogue, and it's like.
Oh, that's when the background music is louder than the dialogue, that's just egregious. That's not an issue of standards. That's just a bad mix.
Exactly. So it's like still professionals still like mess up this stuff, and maybe, you know, don't catch it, or that's maybe it's their style, or you know, it is a, you know, not necessarily a mistake. It's just how they.
Maybe it's it's like the situation in which you're listening to it. It's like you're like, you know, like they do their best to make sure it translates to a bunch of systems, but maybe some choice that they made doesn't translate particularly well to your particular system. Stuff like that. You know,
so
like
confusing.
you can't win them all. So it's all about just like it's like finalizing stuff is really about just making it like as good as you can on the most, you know, checking in the most places you can to make sure it's working as well as you can in most places. And also just having monitoring you trust is a big one.
That's why the visuals sometimes are so much easier. It's like what you see is what you see, and like, you know, there's no like, you're gonna watch it on a TV or a monitor, you know, it's not. Yeah, they're pretty set, you know. There's not a whole lot of variance.
There's so many variables.
Color, I guess.
Like so like, you know, like a screen will look different depending on the kind of light that you have in the room, but that's like the only variable. Right. Really, right? Like more or less, like. Yeah. And you can change that you can turn the lights off.
Oh yeah.
Or like whatever.
You can go in the TV settings and change your warmness and contrast and things, and like. You can do all that to the TV, but like with speakers, like. But
like, imagine if those settings changed when you like moved it around the room, like all the contrast is off now that I shifted it 2 feet to the left. Like that's kind of like what speakers are like, because like they're like sound is always a system that interacts with your space. Yep. Whether you're recording or playing it back, it's always like wherever you are is a part of the system that is creating the sound that you hear. Yeah. And so like I was saying, controlling your space somehow, like whether that's acoustic panels or like. There's this thing called Gobos, which are basically like acoustic panels that are like mounted to be freestanding and moving around. So if you ever seen like people in a recording studio like with like dividers between them, that's what that is. To kind of like block sound from bleeding from one mic to another. There's a whole other issue that happens when you have multiple mics. Like you've heard Jay bleeding into my mic and me not bleeding.
Oh yeah, our setup is not optimal. For, you know,
but it's also like inevitable.
Oh yeah.
Like there's nothing, like if you have multiple mics in a room, they will bleed. Like, you know, there's nothing you can do about it. You can minimize it by positioning them well, choosing good mics, and making sure that the people who are on them are using them well. But like,
I mean, if we still want to like see each other, I mean, if I put a big like, this was a studio room, I put a big glass panel right here, and like there was sound, you know. Then it would probably be like we could still see each other, but I would have to like monitor it so I could hear him, and like it would be, which is what some like TV studios, a lot of them have a control room, and same with a music studio.
It is the norm. Being in the same room as the like ideally, if you were recording audio, the only thing happening in that room is the audio being recorded. You know, but like most of us like don't have a control room and a live room, and so we're sitting there just like trying to be real quiet, like. You know, not shifting your chair too much because you don't want to like squeak the chair. Yeah. Like, so like weird things like chairs that don't squeak. You don't think about that as being audio gear, but it is. If your chair squeaks, you're screwed. We had to switch out the chairs when we recorded those interviews because they were in these and they were squeaking, or they were in some other ones that like squeaked when they like sat back. It was awful though. Yeah, so controlling the sound in your environment, whatever that means to whatever you're doing. Sometimes you're on location and you don't have much control over anything, and the best thing you can do is just put a wind protection on your mic and point it at the source.
Yep.
And that's the job when you're doing that, though. So that's all you need to do. Okay, so mics are positioned correctly. You got them. So like, if we touched a little bit on sample rate and bit depth last time, but I feel like it's worth just mentioning again. When you're recording, you have to choose the sample rate, how frequently your audio is sampled, and then the bit depth is how much information is sampled every time it is sampled. And there are standards for these things. So whether your destination is audio purely or video, you might make a different choice. The two most common sample rates are 44.1 kilohertz and 48 kilohertz. So 44.1 is the standard for music, 48 is the standard for video. I do everything now at 48 and down sample to 44.1 because if it ends up in a video, I don't have to do anything to it, and downsampling is less destructive than, it's better than upsampling. It just makes more sense. Might as well.
Same with frame rate. Like, you don't want to like try to up a frame rate of something.
Yeah.
It's practically, I mean, it really just doesn't work.
You can't like when you have a lower sample rate or lower bit depth, you're just recording less information, and you can't invent that information back out of nothing if you haven't recorded it. So you always want to record it in a higher resolution or like the highest or higher than you think you might need.
Right.
So like bit depth, everything pretty much ends up at 16 bits. But you can record at 24 or now 32-bit recording is a thing. And so the more bit depth, the more dynamic range you can capture without clipping, which is the next thing I want to talk about. We talked about this a smidge last time too. But if you've chosen your sample rate correctly, so you got 44.1 for audio or 48 for video, or just set it to 48 and never think about it again. If you've got all that stuff, you got to set your input levels, right? So this is like the most important thing. This is you can capture like some like bad, it'd be pretty bad if I did this, that's not going to get any good sound. But it's really, really, really bad to clip. And it's like the one thing you can't do. So we mentioned this last time, but digital audio has a maximum. And if you exceed that maximum, either on the way in or on the way out, you get what's called clipping. And so clipping on the way in when you're recording sounds like distortion, because it is, and loses information. You can't get it back. You can't, there are like declipping plugins, but if your clipping is bad, it won't help.
It's like overexposing your footage.
Yes. Very much the same thing, yeah.
Yeah.
So when you get that washed out whites, like there's no information there to get back.
Nope.
So the most important thing to remember about gain with a mic is that when you're recording, it needs to be not clipping. It can be pretty much as quiet as you want, but it can't be too loud.
Right.
So you do run into a problem though, where like every piece of gear has self noise. So like this system without any amplification makes some noise. Mm-hmm. And so the lower I record, the closer my volume is to the self noise thing. When I turn up the preamp, it also turns up the self noise though. So like I don't know, like
it's funny how close it relates to like film on it, like shooting video on a camera. Like you overexpose, you lose that information. You underexpose, and you try to bring that information back. You introduce the grain and the noise into your footage.
It's exactly the same in that regard. Yeah, totally.
It's very interesting, but with light instead of with. It's two different. One captures sound waves, and the other captures light waves. It's really bizarre how like.
I love that there's some parallels that are totally like direct like that, and then some that aren't at all.
It is weird.
It's super interesting. Like, well, mostly because like video's got like another dimension of it too.
True,
like audio is kind of like two-dimensional. It's like time and then like an amount at that time. Yeah. So it's like there's really only like two axes of information. Whereas like video's got like three, right? Because you got your X and Y in the frame, and then like time.
Yeah.
Plus sound, so like 4, I guess.
True. Yeah, I mean, if you just are playing with the video, you've got the visual like thing that it's produced, plus the every frame. With a photo, you're with a still frame. You've got this data of light that you captured onto a sensor, and that's what you have. You have that sensor is then translated into digital information, and there's your picture. But in video, it's that repeated multiple times, and then which gives you that idea of time. So.
Yeah. Oh yeah. Yeah, it's fun.
Mm-hmm.
Interesting parallels and non-parallels. So, talking about self-noise, I think is a good time to mention, if I haven't in the last stream, about grabbing room tone. So, like, when you're recording audio, if you, like, say, like, there's, like, some... Like, if I'm, like, talking and you're trying to catch me, like, in an interview, and I, like make, like, a drop my phone in the middle of a phrase, and you want to, like, edit that out, you're kind of, like, you're screwed, you know? Because you can't separate that sound from the sound of my voice. But if I'm, like, pausing in between words, and I drop that thing, you might be able to edit that out if you were smart enough to grab some room tone. So the idea of room tone is that once your mics are all set up, you've set your gain levels the way you like it. And like you think, like, for your sources, it's not going to be too quiet or too loud. It then is a really smart idea to ask everyone to get the heck out of the room or wherever you are and record like 30 seconds of silence. And because, like, if you wanted to lop out that sound from that pause in my speech, if you cut it out, you just get digital silence, and it's going to sound super weird. Because the whole time, subliminally, you're hearing the self-noise, background noise of our system. So, like, if you want to edit that thing out, you have to replace it with the background noise and not silence. Room tone. This matters more in some kinds of things than others. If you're recording, like, dialogue, like if you're having someone like read an audiobook or something like that, essential. You will have failed at your job if you don't do this. You will be trying to edit, and you will just hate your life when you don't have room tone.
Do even like professional great, like, say we had like a voiceover studio, do those have room noise too? Like, I mean,
every system has some self noise.
It's gonna have, like, because it's the same with, like, I guess on film. Yeah, I mean, I guess it's just the sound. Like, if you have nothing, like that digital silence that you're talking about, it's very uncanny almost. Like, if you were to put that in your film, it would feel wrong.
Yep.
Like, even if it's just a black screen, you want some kind of sound there.
Could just be like a low white noise or something, you know.
Yes.
Pro music tip, by the way, just a quiet. Like, I stick a little quiet bed of noise in, like, almost every track I make.
Interesting.
Because of this, because digital sounds super weird. I don't want to hear it ever. Like, it's, you know, not my music.
Yeah.
It's not what I'm going for. Like, so, like, you might, like, if you're going for, like, a real, like, if you want, like, a dramatic silence, digital silence sounds dramatic. I've definitely heard it used to real great effect in music, you know.
Right.
But, like, it's a certain aesthetic, you know.
That'd be an interesting thing to demo when we do our real project. I think that'd be a cool kind of, although it's hard to do over the stream, at least. Like,
yeah, this stuff is real subtle. Doesn't always come across in the compressed stream.
So, but we can, upload the, a finished version of whatever we do, and then, be a little easier to hear that in that part, in that the digital silence of just like cutting everything out.
Totally.
Like,
yeah.
Cutting everything, but leaving in that digital sound or that like white noise, just like the room noise. Be interesting. I definitely have run into that before, and that was I remember, like, figuring that out and learning that, like, that through trial and error. But that's something that a lot of people don't teach, I guess. Like,
it's interesting.
It's not an inherent, like, oh, you need some white noise in there or your room noise in there to actually, like, bring it to life.
Yeah, I feel like it's partially because, like, at least in my life, it's because it's, like, it's part of a specific workflow that, like with music, this is less of a concern. Because, like, we're not, like, I don't know, if there's silence on a track, like, I usually just delete it. Like, it depends on the kind of music you're working on, though. Like, I tend to be doing more kind of modern, like, electronic-oriented stuff lately. And like, those recordings are, like, it's cool if they sound digital, right. Like, digital silence isn't foreign to those, and you can just check a noise bed anyways or whatever. But, like, if I was recording, like, real instruments in a room, it depends on, like, how much is going on the track and what might mask that noise. Like if the track is, like, say there's, like, really loud drums the whole time. If I record a guitar track, like, and it's got some room tone in it, and then I, like, stop playing, like, the drums probably are going to mask whatever room tone you might hear, and I could probably just cut that out.
Right.
So, like, music has a lot more going on, and, like, in a complicated music track, like, things mask each other, and you can hide a lot of these, like, recording warts underneath other stuff.
Yeah.
And it's like less, you know, it's just less obvious because there's so many more things to like pay attention to when something is a little off or whatever.
True. Sorry guys for earlier. I had my mic muted and was talking. I forgot to turn myself back on. I have to turn myself off because I can. If I'm clicking over here, you guys can hear it really prominent on the stream. That's a problem with this little mic, is that it picks up a lot actually. I don't hear any keyboard noise or clicking or anything like that. Mm-hmm. So
I wonder if you could like. I mean, it's because it's camera mounted. It's like more challenging to position. Yeah. You know, like if you had it like, I mean, if you had it on your desk facing up, you know, the translation from the desk was a problem too. Right. Oh yeah, so that's another thing. Like, you know, like if you have your mics on stands, which you probably do, like, you know, you don't want to be hand holding a mic probably for most recordings. Like they will translate sound from the things that they're on, you know, like, so like having like shock mounts or other kinds of isolation is really helpful. But not all mics like come with that or really need it, you know, like you just not bang on the table too. That's
like our boom mic is on a shock mount. Just, you know, if somebody walks around, you can hear the rumbling and the, you know, this is our place here is the ground underneath is, we're not on like a slab, so it's, you know, you can kind of hear the low rumble of it, and it would be even more prominent if it was not on the shock mount because it's a very sensitive mic.
Totally. Jay, what do you think? Maybe we should record some stuff and then we should run through some post stuff. So I feel like that's a pretty like healthy overview of like kind of like things to think about when you're recording audio, right?
Yeah.
Well, I guess also be monitoring while you're doing it and make sure you got some closed back cans or like some earbuds or something so you can hear in isolation what you are capturing. When you're in the room with your source, it can be really difficult to differentiate your source from what you're actually recording. And so like closed back cans, super important. But I did say that I wanted to talk about some post-processing stuff too today. And so I think what I'd like to do is just, I'm going to capture some audio with this mic and then I'm going to process it and show you guys a little bit about that.
All right.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software. But the things I will show you how to do are tools that apply to all audio programs. Any digital audio workstation or audio editor that is meant for this kind of job can do these things. So there's what I think of as five main tools for audio post-production. So you've got your stuff recorded, you're ready to mess with it. So the five tools, in my mind, are volume, big one, right? Panning, EQ or equalization, dynamics, which usually means compression, and reverb. So I'm going to demonstrate a little bit about each of those tools. I just recorded myself saying all that, so we'll mess with that audio. We might be able to actually, oh, you know what just occurred to me? We can probably just mess with my audio live since I'm not direct monitoring anymore. Well, but maybe it would be a better illustration to, no, we want to process it while I talk, so. Jay, is the boom on again?
Yes, it's been on.
Okay, cool. I'm gonna turn the monitor off on this then.
Okay.
Cool. So now I gotta listen. So I said the tools were volume, panning, EQ, compression. So I'm gonna pull up something to do each of those things with. So volume control is already built in. I'm gonna get out an equalizer. I'm gonna get out a compressor, and we have a reverb send already. So dope. Okay. So Jay, are you getting this? So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
Sounds great.
Great. So I wonder if I can just play this without hearing it because I want to talk over it. Let me figure out how to do that. Oh yeah. I could probably just okay, great. So I'm playing the audio back. So this is not what you're seeing here is the equalizer. So it's a representation of all the frequencies in what I was saying from low to high. This is like probably the first tool that like really like bears a ton of explaining. I said volume is one of the things, right? Maybe we'll start there actually. So this clip. So the program I'm going to use right now is Ableton Live. Oh, do you hear that P kind of pops? So the program. Can you guys hear that? Little bassy P. So the program. That's called a plosive. And it's put it's when you make a P or a B, you puff out a little puff of air, and when you blow it into a mic, it creates a bass noise, which is so the program. You can even see it, the low frequencies down here jump. So the program I'm gonna use. You see that? So the program I'm gonna. There it is, my plosive. Just want to point that out. Something to look out for. So like this is why we use pop filters on mics often. That's more likely to catch it than this thing. But so like if we listen back towards like a later section of this, it's meant for this kind of job. Can do these things. So like this word, listen to this. So like I got off mic and you can hear this word job is quiet. Or audio editor that is meant for this kind of job. Right? I accidentally drifted off axis. So when I was saying volume is one of the things we can do, like you might go in and just like, if before you do anything else crazy to that, you can just go in and turn this individual word up. So I've separated it from the rest of them and just turned its gain up. Any digital audio workstation or audio editor that is meant for this kind of job. Oh, I grabbed the wrong thing though. Whoops. So I just added about 3 dB a gain. Audio editor that is meant for this kind of job. And that's a lot better sounding.
It's an interesting way to look at the wave.
Audio editor
it's
that
not what
is
I'm
meant for this kind
used
of
to.
job.
As far as like having like where you can see the like the actual wave itself.
Well, I'm really zoomed in down here.
Right.
But like, yeah, if you zoom in far enough, like there's the wave form in all of its glory.
Maybe.
So it looks really complex.
Yeah. Maybe I just.
There's okay, like we could spend some time on the math of this, but basically, like Fourier showed us that any wave can be recreated by an infinite number or a smaller than infinite number of sine waves. And so a complex wave is just like a bunch of different frequencies all being played at once at varying levels and for varying lengths of time. So that's why even though this wave looks really gnarly, it's just one thing. And that's how like every sound wave can be represented in like one wave, you know. So you notice like this kind of like repeating shapes here. It's like a waveform in a synthesizer almost.
Yeah.
Don't point that out. You know, like it's just how sound works. So like when these things repeat, like that's like that frequency. That's like the pitch of my speaking, right? And then the like the stuff that's going on in between the repeats is like the timbre or like the tone of my speaking. It's one way of looking at it. Kind of interesting. I don't often like get deep into the waveform like this.
Yeah.
Ableton's not a destructive editor. Like there are some programs where you can like literally like draw on these and smooth them out. Pro Tools lets you do that. It's an interesting Pro Tools feature. But yeah, so volume is your main tool, right? So like making sure that things like match level wise, you know, like if you like have some bit of dialogue where someone trails off, turn it up. All audio programs, you know, like for this kind of job. Yeah, so like that worked a lot better. So like there's other tools you could use to try and mess with the volume, but just turning the thing up or down when it needs to go up or down is like the main thing. I feel like volume's pretty straightforward one. So there's also panning. I feel like panning is pretty straightforward too. Generally when we're doing music and most kinds of audio, we're thinking about a 2.0 playback system, which means they're a 2-channel playback system, left and right audio. So that's what Ableton's equipped to handle here. I can use the pan controls over here. Oh, if I, not the send, but the pan, to pan that thing left and right. So the program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. But the things I will show you how to do, that's pretty clear, are panning tools that apply.
That should come across on stream too.
Hopefully, y'all are getting a stereo stream. This is probably more relevant to like music and like narrative applications. Like it seems like mostly dialogue is centered. Unless the character is off, like moves off camera, like to the right or left, in which case, and if they continue to speak, like the dialogue may follow them off camera. But like podcasts, actually, please, if you make a podcast, do not pan your hosts. Please don't. I listen to a podcast that has 3 hosts, and they are panned not hard left and right, but like left, center, and right. And so if I would listen with one ear in, one of the guys is way louder than the others, and one of the guys is way quieter. It's just, you know, and like who's all like, you know, always got both earbuds in when they're listening to like comedy podcasts. So please don't pan your host in a podcast is my advice. Unless you really need to create a feeling of stereo for some bizarre reason. But in music, we pan stuff all the time. Like, it's all about using that stereo field creatively and interesting. Although vocals and lead vocals tend to stay in the middle. But, I might pan, like, if I was going to sing a double of this, or I might sing 2 doubles and pan them left and right or something weird like that. So you can do stuff like that. Less relevant for voice than for other kinds of things. So, next tool, EQ. So EQ, I'm going to pull up this big old window so you can see it real good. So this is, like I said, this is representing the balance of frequencies in my voice. And so, like, getting used to reading this is kind of crazy. You see there's a lot of, like, peaks. There's a lot of different frequencies going on. There's some of every frequency being represented here, right? But you can also kind of see, Jay, do you get the impression that there's, like, you see where there's a spot where there's not much information below? Like, kind of around here?
Yeah.
Like there's the occasional off. Like jump up below here, but all the business is happening like above this spot, right?
Right. Is that marked or have you marked it already?
That is marked.
Okay.
This is a logarithmic scale, so this is 100, and this is 1,000, and this is 10,000 over here. I know it's kind of weird, but our hearing works logarithmically. So like something that is twice as high or like double the frequency, like sounds like the same note. Like it's just a weird thing about how hearing works. So like viewing frequencies in a logarithmic way makes way more sense and is a more musical way to deal with it than if I've seen EQs that do it like linearly, and it's really uncomfortable looking.
It's so fascinating how much more complex hearing is than I mean, like seeing is complex. But when it comes to, like, the science of it, I feel like what we see is kind of what we see. I guess there's, like, optical illusions that kind of trick our eye into things. But, like, and I guess there could be optical illusions in sound.
Oh, yeah.
Like, definitely, like, weird kind of bizarre noises.
Totally are.
But
shepherd's tone is a famous one. It's it's a sound that constantly rises.
Oh, yeah. I think I may have heard that.
Not shepherd's. Oh yeah, here. Check
out
out shepherd's tone.
That sounds really good.
Just gonna play. It's here we go.
Like a spaceship taking off. Does it just keep going until we can't hear it anymore?
No, it just keeps going. It's an auditory illusion. My YouTube history is showing. It's kind of embarrassing. It's not embarrassing at all. George Jones is great.
You got that lo-fi hip hop.
I pulled that up for a student the other day. Yeah, I've got this stream actually in my recommendations. That's kind of cute.
Oh yeah.
Good job, YouTube. Anyways, this is a shepherd's tone, constantly rising. So the idea is basically you introduce a new lower tone. So there's like as it's going up, there's always a new lower one coming in below it. That's what you're seeing here in this graph.
Interesting.
So like at this point, there's like 1, 2, 3, 4 different tones, or 5.
Bizarre.
Anyways, shepherd's tone. So there are auditory illusions as well.
It just seems so much more.
You still got
complex.
my feed?
Oh, whoops.
Yeah.
There you go.
Just making sure.
Yeah. Huh.
Yeah. Anyways, so EQ. So the thing I want to point out here is like I wish it was easy to like freeze a moment of this in time.
Oh, it goes away if you stop. Yeah.
Yeah, you can't like. Oh, you can turn the refresh rate really high. Oh, that's not it. So, anyways, the thing I want to point out here is that like there's like kind of like a lowest spike here, and it moves, right? But there's like a point where it's lower, and you can kind of see these like few spikes that are moving like in parallel together, right down here. The lowest one is what we call the fundamental pitch. That is the note or like the pitch that I'm speaking at. Everything above that is what we call timbre information. So that's like the tone of my voice. Is whatever like where I'm going or eh. That's timbre, right? Ooh, timbre. You can use this information to your advantage, though. So what we can know about this is like below the fundamental frequency, there is not really any useful information. You know, subharmonic sounds don't exist. Like when you strike a low note, like a low E on a guitar, it doesn't make any sounds lower than that, really. Well, it kind of does make a thump, maybe. But for voice, like for my voice, if I start cutting out the frequencies below that fundamental, you should not hear it at all. And it should sound exactly the same, except it'll stop pushing out so much high energy, low frequencies. So I'm going to use what's called a high pass filter. So let's listen to this real quick. So the program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. Cool. So if I bring this thing up higher, like past the fundamental. So the program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. But the things I will show you how to do. Yeah, so you can hear as I start cutting out the lower frequencies, it starts becoming less audible. Or audio editor that is meant for this kind of job.
So why do phones sound like that? Is it because they cut those low frequencies so that it's easier to send?
It's actually kind of interesting. So real quick, so like a telephone EQ like kind of ends up being more like this.
Chopped off on either
So
end.
the program I'm going to use right now is Ableton Live, because that's
without all the sparkly
my
highs.
most comfortable piece of software. But the things I will show
It's
you how
very
to
much
do
radio sounding
are
too.
tools that
Yeah.
So there is a psychoacoustic reason for this. That's a fun word for psychoacoustic. Sounds crazy, but that's just the word for like the intersection of our psychology and our hearing, right? So like things like the Fletcher Munson curve, which are like based on like how our brains and our ears interpret signals, you know. Part of one thing you can learn from that Fletcher Munson curve. Can I get that thing back? Actually, where'd you go, Fletcher? Is that like you can see you see where the lowest point is here? It's like kind of between about 2K and 5K.
Looks to be right in there where you had it.
Yes.
Equalized.
Not a coincidence. Those are the frequencies to which our ears are most sensitive. Those are also the frequencies that help us understand the sound of the human voice. And that is why our ears are so sensitive there, I think.
Interesting.
So this is maybe like a little anthropomorphizing of evolution, but like it's really important as a social species that we hear each other and understand each other and communicate. So like our ears have evolved over millions of years to be real good at that. So let me illustrate this. I'm going to bring this to a different section of the spectrum, and I think it will be harder to understand if I did this correctly. So I'm gonna bring this a little tighter. I said remember 1K to like 5K, so that's this now. So the program I'm gonna use. So if I bring these guys down.
So the program I'm going to use right now is
Yeah, it's very muffled.
Yeah, you can hear the note. If I was singing, you still hear like the note I was singing, but it's really hard to make out the words now.
So the program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. But the things I will show you how to do are tools that apply to
right. So right around here is like becomes easy to understand again.
Any digital audio workstation or
like
audio
that's kind of hard.
is meant for this kind of
That's pretty cool too.
So there's 5.
But right there is the sweet spot.
Interesting.
So
That's really cool.
You're ready to mess with it. So the 5 tools.
You know, like obviously the more information the better, right?
Right.
So the phone system, like phone speakers, like the compression of digital audio over the phones now is like designed with this in mind. That they'll just chuck out tons of information. Who needs the sub bass?
Right.
No one's singing bass lines into their phone, and if they are,
Just to make it as efficient as
yeah.
possible. Right.
So like file compression is all about efficient transmission, right? So like anything you can chuck out that's not necessary. So this is like why MP3s MP3s throw out a bunch of high frequency information. There's really nothing above 15 kilohertz in most MP3s. But it doesn't matter because most of us can barely hear up there anyways. My hearing starts to roll off pretty hard around 15. Yours probably does too. Although you have less hearing damage and you're younger than me, so yours is probably a little better. Being a musician is it's definitely takes a toll on your auditory health. wear earplugs, and you guys, it's important. Anyways, EQ. So like, if I was trying to use this to instead of to create a telephone effect to like solve some problems here, with problems. The thing like I'm noticing is like there's like,
so the program
I know you see that like big spike of low frequency information there.
My most comfortable piece.
Like in that plosive, I can like kind of reduce the thump of that by filtering out those low frequencies. So like,
so the program.
I'm just seeing if it
program
sounds like
the program.
You know, almost like a bass noise. Here, right? If I you could probably use that as a kick drum if I EQ'd like.
Oh, yeah.
You know, fun. But I want to get rid of that. I don't want it to be so thumpy. I don't like how that sounds. So I can go up here and just kind of carve away at those frequencies. What I don't want to do is let this curve adjust the like either boost or cut up into my fundamental area.
The program I'm going to use right now is Ableton Live.
Which, I mean, it would be fine if I did, but I'm trying to do this as transparently as possible.
The program I'm going to use right now is Ableton Live, because that's my... The program I'm going to use right now... It's
a slight improvement. Unfortunately, that plosive is kind of like close to where my voice actually gets. So I probably have to carve into it a smidge to actually get it.
The program I'm going to use right now is Ableton Live, because that's my...
But here's a fun fact. You can pretty much EQ out the fundamental most of the time for people's voices, and it doesn't sound too weird. Check this out.
The program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. But the things I will show you how to do are tools that apply to all...
It's not very rich sounding anymore, though, right? Like, if I bring that low frequencies back...
The program I'm going to use right now is Ableton Live.
There's that, like, announcer, like,
comfortable piece of software.
Radio voice kind of thing. So you can use this as, like, an adjustment tool, too. Like, I can maybe, like... I can come up in here.
The program I'm going to use right now is Ableton Live, because that's my
do something
most
like that
piece of software.
Or if I want less bass, I can do that.
The things I will show you how to do are tools that...
Basically, I'm just creating a curve here that's like a representation of my idealized adjustments, you know? So another thing you can do sometimes, like, there's a bunch, like, this tool has a bunch of different curves that you can use. There's like high pass curves, and there's these bell curves, which look like this. Then there's, I think we demonstrated this last time, right? Like shelving filters. We've talked about this at some point. Not last time. But. So like things I might do, like, remember we talked about how like voices are, like voice intelligibility is here. If someone sounds a little muffled on the recording, you could boost, like do a broad and gentle boost here.
The program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. But the things I will show you how to do are tools that apply to...
That's a lot of gain. That still sounded all right. That's shocking, actually. That's a ton of gain. I would never do that much on a real application, I don't think.
The program I'm going to use right now is Ableton Live, because...
Another nice thing to do for voices, so like a boost up there usually sounds pretty good on voices. Another nice thing to do is a little dip down here, somewhere between like 3 and 5.
The program I'm going to use right now is Ableton Live, because that's my most comfortable piece of software. But the things I will show you how to do are tools that apply to all audio programs.
So here's like before.
The program I'm going to use right now is Ableton Live.
Here's after.
The program I'm going to use right now is Ableton Live, because that's
not a big difference, right? You should not hear a dramatic difference. I'm not trying to. I'm just trying to like sort of like make a little more space. Since this is the only, like, if this was an audio, like a vocal track, like I'd do stuff like this. If this is just a voiceover, I'd probably not mess around with any of this. And I'd only like touch this if I was like, there's a problem. The low frequency rumble is to my mind a problem because of what we're about to do next. We're about to get into the dynamics processing. What was that? There it is. A little bit. Is that all the zoom I get? Oh, come on.
I think it goes...
This thing's just hard to see. Are you able to zoom my screen over there?
Not too easily.
No, it's okay. We're just gonna like. I wish this compressor showed like a bigger window like the EQ does, but down here is our dynamics processing module. It's called a compressor. The idea of the compressor is like it lets us turn down the loudest sounds so that generally we can turn up the sounds that are quieter. But basically, like, you can use it as a tool to smooth the volumes of stuff. So let me show you how it works. basically there's a couple main controls. The threshold chooses above the level above which the compressor engages.
The program I'm going to use right now is Ableton Live.
Then the ratio is how much it is being turned down when it exceeds that threshold. And then the attack and release are how quickly it reacts. So I'm going to leave these settings just like how they are and just mess with the threshold and see if we can hear the difference. So it's like...
The program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
You hear it turning me down, right?
I'll show you how to do.
This orange meter is the gain reduction.
The program I'm going to use
so that's
right
how
now
much
is
it's
Ableton
turning
Live,
me down.
Because that's my most comfortable piece of software. The things I will show you how to do are tools.
So the advantage of doing this is that now we can turn it up. There's actually an automatic thing. If your compressor has a button called makeup or control for makeup gain.
The program I'm going to use right now is Ableton Live because that's my most comfortable piece of software. The things I will show you how to do are tools.
So without compression?
The program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
And with?
The program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
So you can hear it sounds really like smushy. Like, that's the technical term. We like to be like squished or squashed or like glued or gelled. We like these kinds of terms. Like it kind of makes things like cohesive sounding. And just sounds like a little more pro. Do you know what I'm talking about? Like,
so the program I'm going to use.
This is like a lot too much compression. I wouldn't use this much here, but like.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software. But
like a little bit of gentle compression, like can aid in making things feel more even, like throughout the whole thing. You just got to be careful. This like the threshold is very much dependent on the thing you feed it. Like if I started yelling a bunch and then whispered a bunch, like this compressor would probably like. It would help maintain those volumes better, but it would you might set it differently if you're gonna feed it some dramatic stuff. Yeah, it's still a better habit to like if you have something that you're like, oh, that's just too quiet, it needs to get turned up, or like that's too loud, it needs to get turned down. Like it's probably better to go in and do it with volume first, and then think about the compressor as either like a smoothing effect, like a leveling out effect, or as like a coloring effect. That's more relevant for the music people than for like the video or like podcast folks, but like different compressors add like some interesting color. This is a very clean and clinical one, like for just doing the volume managing job, but it works really well. There's other interesting dynamics processing tools that I don't use as often because like I do music and they're like not as relevant to the kind of music I'm making, but like the opposite of a compressor is a gate. So like say we wanted to, for some reason, cut things out to digital silence, or we use a gate. Basically, when things drop below the threshold, they get quiet.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
So yeah, I got out my like,
because that's my most comfortable piece of software.
Without the gate.
Because that's my most comfortable piece of software.
And with it. Because
that's my most comfortable piece of software.
That's pretty effective. So you might set this just like kind of like cut out like some like low noise. Of course, if you're like, if I'm pausing between everything, one of these things going, then like that's too loud and like a gate won't help. But like if your source is something that can be gated, a gate could help you. That makes sense. What did I say the other things were? Oh yeah, reverb. I've talked about compression on here before, and I feel like I could like talk an entire stream about compression and probably sound like a fool and have a bunch of people correcting me. But it's a really complicated subject, and there's a bunch of different uses for it. And yeah, anyways, this is a great. If you want to know more about that, maybe you should make an appointment with me at MARZ, and we can talk about it together. Yeah. So I just want to say a little bit about like reverb real quick. I'm gonna pull out a different reverb because I'm always using the little plate. I'll pull out the live default reverb. So reverb is the thing that lets us put sounds into an acoustic space. So like if say you had something that had a bunch of digital silence in it and you like didn't want that, you could sort of like mask it by simulating a reverberant space with a reverb effect, right? So like, I shouldn't have deleted that gate because yeah, let's do that because we'll have some digital silence to play with then. So
the program I'm going to use right now is Ableton Live.
So like you're hearing the sound of my room there. If I turn this reverb send up, I'm gonna add some reverb to this.
So the program I'm going to use right now is Ableton Live.
Now that's a pretty nasty sounding room that no one wants to record in. But this reverb has a bunch of different settings. We can do things like cut out some of the frequencies. I'm gonna like balance some of the stuff. I'm gonna set the quality higher. I'm gonna turn some of these reflections off. Add a little pre-delay more. Turn the decay time down.
So the program I'm going to use right now is Ableton Live.
So it's almost like a big bathroom or something like that, you know. So that's like too much. You can turn it down a bit.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software. But the things I will show you how to.
So now, like I think I've kind of gotten it to the subtle level. You can hear it ring out just a little bit.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
That didn't really cover that silence very well, did it?
Where did it?
I think if I had the decay time long enough to cover that silence, it would sound pretty unnatural.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software.
It's kind of a fun effect, but not very functional.
Yeah.
There's probably a better choice for like a actual space simulation than this particular reverb, which is this is what's called like an algorithmic reverb. They also have like there's another kind of like if you're looking at reverbs and trying to simulate spaces, you might want an impulse response reverb like this one, which we can set to. Here's
Oh, you can pick different rooms.
Beersheba Town Hall. That's funny. That's the town in southern Israel that I went to. It's one of the oldest continuously inhabited cities in the world. There people have been living there for 9,000 years.
Wow.
Pretty wild. Or something like that. I was gonna show the hybrid reverb. So this I have this set now to like the basically this lets you choose a bunch of different recordings of actual spaces. So I'm gonna choose some real places, and we're gonna put me in. I don't want these weird places. What's a normal place to put me in? Small. Here you go. Intimate space. Live ER. Weird. I haven't checked any of these out. Let's check out Woodroom.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software. But the things I will show you how to do.
So cool. So I haven't covered up any silence, but it now sounds to me like I'm in a different room than I was in.
So the program I'm going to use right now is Ableton Live because that's my most comfortable piece of software. But the things I will show you how to do are tools that apply to all.
Tools that apply to all. Did you hear that?
But the things you are tools that.
That gate is set too aggressively, and I cut off the T of that word.
Are tools.
So yeah, I don't really use a gate very often because I find that to be not precise enough. If I need to cut that thing out, I'll go in and cut it out and replace it with room tone, which I did not record. Oh, there's a little room tone. That's just a breath. So if I was to be really smart, I'd like shut the heck up for a second. And record some room tone. So now, like, I can like go insert. I figure I should just demonstrate this because we're talking about it. So like,
I will show you how to do are tools that apply because that's.
So say I want to like get rid of that like little dithering whatever like thing I did. I can just paste in a little bit of this room tone.
Because that's my most comfortable piece of software.
Done. Simple room tone. Sounds super weird if it's nothing there.
Because that's my most live because that's my most comfortable piece of software.
It's so interesting. Listen to what's happening there. It's like nothing. It's like hiss. You're hearing like sound of our room, but it's just enough. Like the silence is uncanny. That's a great word to put it. And it's just a little bit of room tone is just enough to like put you back in like reality again and like ground you. So super important. Gosh. So with the the actual impulse response, like reverb space kind of thing, like I imagine this tool will be really handy for like video folks who are like trying to ADR anything. Like if you ever have to like record dialogue not on set, matching the sound of that dialogue to the sound on set is crucial. I bet you anything that in real pro productions, they're taking an impulse response of the rooms so that they can feed that into one of these reverbs and literally use the sound of the room they recorded in as a reverb. Let's put this thing in there as an impulse response.
My most comfortable piece of software, but the things I will show you how to do are tools that apply to all audio programs.
I think that's a kind of a clear illustration of how it works, huh?
Yeah.
So like here, if I solo the reverb,
It's interesting.
unpleasant. So it's like it's basically like using this sound as like a resonator and exciting it with the sound of my voice, right? So you could probably put all kinds of wacky stuff in there and have it sound cool. Now I'm like super curious. I'm gonna try one more weird one. Here's the Apple II boot sequence. Oh, I can't use that for some reason. Is it too long? I think these are wrong file types. Right, here's some
Happy
biting out.
wave.
What?
That's like you're in space. Sounds very,
I do not know why it did that. That was so weird. I'm going to explore this later. Okay, that's a fun thing you can do, apparently.
Cool.
Oh, gosh. And now here's my whole folder. Yeah, right. Ugh. Surprises. So, I feel like that's a pretty healthy overview of, like, some, like, basic audio post tools, though. For your, like, specific application, like, there's going to be different things that make more sense for you to use. Obviously, like, I'm a music guy, and so, like, the tools I'm using are music-oriented tools, but they're the same things that you'd use for like video posts too. Like it just looks different,
Right.
And then obviously you get more hyper specialized when you're trying to do more specific tasks. And I'm using generic stock versions of all of these plugins in Ableton. Your program that you're using probably comes with their own versions of these same tools, and there are also third-party plugins that you can get. For music, I tend to reach for third-party stuff for a lot of these tools, just because I like using the kind of like vintage like modeling plugins. So like I'll use instead of like that compressor, I'll pull up like the I can't show you because I don't have my Apollo plugged in. But I'll pull up with like the UA like 1176 compressor or something like that, which is like based on a hardware unit. It has like controls like a hardware compressor. So it's a little more like takes the kind of like math and graph reading out of it and kind of like forces you to use your ears.
Yeah.
I like that. But like that's a music thing, and so like. So a lot of times if you're doing like video posts or stuff like that, you're often more like problem solving, and so and then also like when you're at the point in post where you're like looking to meet standards like we talked about earlier, like loudness standards or whatever, then like metering is like really really important,
Right. Yeah.
So like if you're so like there's like like I said before, there's like compressing for like color and tone, and then there's compressing to like solve a problem, and so like my tools are more for color and tone because it's music stuff, and then we solve problems later.
Yeah.
It's like it's not unusual to like in music production to do multiple stages of several of these processes. It's not unusual to have like to record through a compressor on the way in, or have like one and then a second one just right after it, and then maybe it gets compressed again in a group.
Interesting.
Which means, so it's like in music, a lot of the processing gets really cumulative. So you have to like keeping track of your signal flow, like where, like what processing each sound is going through. Because you can like, when things get complicated in here, like you have like one track that feeds another track, that feeds another track, that feeds the master track and stuff like that. And so like you can have all these like different points where you can apply processing to multiple things or just one thing. So just, if you start doing a bunch of dynamic, like compression is where that gets out of control and you start to like forget and like the interaction between the different ones starts to get really confusing. So it's like just being mindful of your signal flow is really important. But there's nothing wrong with using multiple compressors or something, or multiple EQs if it's for some reason something you need to do. Just be mindful of how it sounds. In music, the only rule really is if it sounds good, it is good. For other, but I mean, there's also like some like sort of guidelines. Like you don't want your lead vocals buried by the bass. You know, like you want your instruments to sound balanced. You know, like for film, you want the dialogue to be audible above the like the background music, but you want the sound effects to be nice and present. You know, there's like some like desirables, but there's like it's interesting because it's like it's creative, but it's also problem solving. You know, so like it's interesting like a cross between those two things. It's not purely creative, but it's not like the mixing and post production stuff. But it's not purely just like checking off boxes. You know, you get to make creative decisions too. I really enjoy doing post stuff, like especially like for like vocals are like really fun to work on. Oh, is there an audio problem? You just gave me a look.
I'm getting a weird buzzing.
A weird buzzing? I guess I'm not gonna hear it up here, huh? It like just started.
Yeah.
Weird. Huh.
It doesn't happen when you're talking.
Oh, that's interesting.
Or
so,
it only happens when you're talking.
well, that's even more interesting. So is it like this? Is it this mic like picking up?
I can't hear it anymore.
Oh.
Who knows? Could be OBS.
My phone?
Maybe.
Oh yeah. Hey, while we're talking about preparing for audio recording, this is pretty essential. Turn your phones on silent, but also like turn it on like airplane mode maybe, or get it the heck out of the room. Unless you have like really nice equipment, and maybe even if you do like super high end isolated cables and all that crap, like good cables, whatever. Cell phone interference will get picked up by your mics, by your speakers. It sucks. I have Yamaha HS8s at home, which are really popular studio monitors, and they're not shielded very well. And anytime someone sends me a text, I get like beep, 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 through my speakers. So if my phone is on my desk anywhere, I have to like put it somewhere else. So yeah, that can get captured in the recording too. So it's something to be really mindful of. It's one of those things where it's probably not going to be a problem. But this is why you monitor while you're recording. And if you're doing the kind of thing where you're not going to get a second take, like if you're doing something like a live interview or something like that, where it's like oh, let's redo it. It didn't sound so great that time or whatever. Where that's not an option. Like you want to just be sure that you're capturing good audio. You know, so it's like a good idea to err on the side of safety with that kind of thing. And then controlling the noise will set you up for easier post processing. So yeah, I should also say this too. The better you prepare and the better the actual recording goes, the less post-production there is to do. Crucial. So yeah, just going in with a plan and being ready to follow through. That's the thing. Yeah, I think I'm out of things I want to say on this subject though. I do plan on condensing some of this information down into a more bite-sized access class, which we're going to shoot in the next couple weeks here. But I think that'll be more geared towards like just like pure beginners and just like nuts and bolts stuff. So if any of you are curious about more of this stuff, hit me up. I'm here at MARZ. We're here to talk about this stuff. We love it. As always, feel free to shout at us on Instagram or do something weird. Are you hearing that? What are you hearing?
It's like a crackle. It's not really a noise. It's like a tick, tick, tick. Like.
Does it get worse when I do this?
No.
I'm so curious if it was my phone. Well, we may do some audio troubleshooting when we come off the air here.
Yeah.
Yeah, so I guess this is an illustration of how, like, no matter what you do, things can go wrong. And so, like, Jay's not been monitoring the audio this whole time because he's been trying to talk, and it's super frustrating to talk to someone when you're hearing your voice on a delay in your ears. But so this is why it's really nice to have, like, audio person on set.
Yeah.
You know, or like really why it's nice to like not be both the talent and the tech, you know.
Yeah, I end up like stumbling over myself because I like I'm hearing myself. It's about like a 7. I think I've got it set to like a 7-frame delay in the system, but then it's also delaying just like the feedback because I'm monitoring through OBS. So it's like it's kind of like talking to yourself almost. Like
7 frames is like a lot of milliseconds.
Oh yeah, it's a good. So like I'm trying to say something and then I hear myself and I'm like that listening and speaking to yourself at the same time is really weird.
Yeah.
And it's so I would, if I could mute myself I would, but the particular way we have it set up right now will not work that way. Yeah,
it's always nice though to like not have to do double duty if you can avoid it. I mean, like recording yourself doing music is one thing, like when you can like turn it off and do another take, but like in a situation like this where we're like live and like,
right,
like something can go wrong when Jay pops his headphones off for a moment and he won't know until he puts it back on.
True. Yeah, like this little weird crackle.
Like whatever this crackle is that's hearing. My headphones are straight out of my box up here, so I can't hear what's on the stream right now. But apparently it's not great. We'll find out.
Yeah. I mean,
it'll be interesting. We'll watch it back, Jay, and we'll see if it's in your monitoring, if it's actually being recorded.
Okay.
Because it's possible. Like, I think I mentioned about my old bad headphone amp, right? Like,
yeah,
you can be fooled for sure. So
I can't hear it anymore, so we'll see.
Find out what it was.
Alrighty.
Well, cool. Thanks for hanging out and listening to us blab.
Yeah.
Gab. Next week is Mo.
I think Mo's coming in
from Access.
Yeah, I'm not sure what she's gonna be covering. Actually, I gotta maybe bring it up real quick. I think we have a Google Drive file somewhere. Let me see. Just to let you guys know what we're gonna be doing. We will probably put out some stuff for it. So it looks like Mo is going to be doing, let's see, she's got a few listed down here. Creating media with what's available, PSAs and Access Humboldt channels and radio, photo essays, Zoom events, using Zoom for productions, intro to stop motion. Ooh.
Fun.
There's a few listed on there. I'm not sure which one she's going to do, but
interesting stuff.
I look forward to seeing what she comes up with. And cool. All right, guys. Well, Corey, you want to say goodbye?
I sure do. Thanks for watching, y'all.
Yeah.
See you next time.
Bye, guys.